Okay, so, sorry. Okay, so we left off yesterday implementing our optimal strategy based on the lookup table that we found on Wikipedia. Okay, and today we are going to change our shoe. Okay, so this is all code that was running the optimal strategy versus the simple strategy, and we saw that not yesterday but on Wednesday. And today we're going to implement an actual shoe. So up until this point, every time we called the function shoe to draw new cards, we treated it as if we had an infinite number of decks and that every card had an equal probability of being selected. Okay? But in blackjack, usually you have a shoe maybe consisting of 6 decks, sometimes more, sometimes less, and you can count how many aces you've seen, how many tens you've seen, or how many low cards you've seen. And the idea being that if you see more cards that are of low value, that then increases the probability of seeing tens and aces. And thus, it increases your probability of getting a 20 or a 21. Okay? So one simple method for counting cards is called high-low. And high-low, I'll just do counting cards blackjack, okay? And then let me see if I can hear this. Okay, so we have card counting, and this basically this is the card counting strategy, high-low. So 2, 3, 4, 5, and 6 are each worth +1, meaning when you see these cards show up in a game of blackjack, it increases the count. And then if you see a 10, jack, queen, king, or ace, that's worth -1. The rest are worth 0. Okay? And so if you see a whole bunch of low value cards, that increases the value of the count, and that you might then change your bet to be something higher because now you are anticipating getting 20, 21, some kind of a good hand. Okay? And the dealer also has a high probability of getting a good hand as well, but because the dealer has the rule that they can't hit over 17, it favors the player in this case. Okay, and so you'll notice if you add up all of these numbers, all of the +1s and -1s, it evens out to 0. Okay, so over the course of play, the count should be around 0, but because you've got 6 decks in there, it could be as high as +30 or something like that, or as low as -30 if you see all of the 10, jack, queen, king, aces. Okay. So anyway, to implement this, we have to create a reference class object. Okay. So we talked about reference class, I think, last week, and with a reference class, you now have the attributes in the reference class are mutable, meaning when you call the method for the reference class, it actually changes the things in the object. Whereas everything else, all of the other functions, you take in the argument and then it outputs the results. With a reference class, you can take the argument in and it actually changes the object. Okay, and so we're creating a shoe object, okay, capital S shoe. This is a new reference class object called a shoe. And there are 4 things that exist in the reference object, 4 fields, okay? The decks, which is how many decks we have, so it might be like 6 decks by default, or we can increase that to 10 or 4 or whatever. So maybe, this will probably be like 6, okay? Cards will be the entire vector of cards. So if you have 52, if you have 6 decks and 52 cards, you will have 312 numbers in this field cards, okay? And this will be all 312. It'll be as if somebody went through the entire deck and wrote down the value of every single card there. So anywhere from 2 up through 10 or ace, okay? And this will be position, okay? So normally when you deal out the cards on the deck, it reduces what happens. But in order to kind of simplify our programming, we're just going to keep track of our position. So when we start off, our position is 0, but then as we draw cards, we're going to just increase our position in the stack of cards, so we can say, okay, the next card that we're going to draw is an ace, and the next card we draw is a 5, things like that. So all we're doing is we're just moving through the entire stack of cards here, okay? And debug is just to help us debug, okay? And so we then implement a few methods for our reference class. The methods that we're implementing are shuffle, draw n cards, the number of decks left, and played. This is a convenience function for us. So shuffle will just take all of the cards and shuffle all of them. So the shuffle decks is another function from way back, which basically just takes all the cards and samples from them. And then draw n is just, all we do is we just take our position in cards, and then we look at the next n cards, okay? And then we draw those cards from the deck, okay? Or we say these are the cards that were drawn, and that's returned to us. But we see the super assignment, meaning we are changing the position field in the reference class. So, if we start off at position 0 and we draw 10 cards, our position will now be at 10. So that the next time we draw cards, it will draw cards 11 through n, okay? And then we also have just, if the number of decks left is less than or equal to 1, shuffle the cards, okay? So in Vegas, there's usually a little plastic card that says this is the time when you reshuffle all the cards in the deck, okay? And so here, and then we just have decks left, which is what's being called here, which just says how many decks do we have, and then we look at the position divided by 52. So as the position increases up to, like, say, 260 or something like that, then this will say, you have run through maybe 5 decks or something, and then so you now only have 1 deck left in the shoe, and then that calls it to shuffle. And then played is just so if we call reference class, not the reference class, if we call shoe played, then it will tell us all of the cards, and this just says from 1 through the position. So if we've played, if our current position is at position 50, this will return 50 cards, being the 50 cards that we have played. All right, is this reference class object okay? All right, and then so we can create a new shoe, okay, and all this does, this is a function that just assigns some default values to our reference class object, okay? And so a new shoe is going to produce a new reference class object of type shoe, okay? And then so it creates it, and then it shuffles it, and it gives you our shoe here. Okay, and so when we can then implement this and play a few games here, okay? And so in your midterm exam, the last question is going to deal with playing a game of blackjack here, okay? So, well, let's see. I think I'm just gonna stop there, and I'm gonna stop the video here. Just this is the explanation of the reference class object and the call to the function shoe. I'm gonna stop the video here.